Good evening, everyone. Welcome to this Embedded System Design, IoT and PCB Design Masterclass series. I warmly welcome you to the session. Thanks for coming and thank you for your time. And today's topic is about challenges in embedded system design and how to, what are the components in embedded system design and the basic difference between a normal OS and the RTOS. So before we go into the session, I would like to welcome you all for this event. First, I would like to welcome the early comers first. Uh, Diksha, good evening. Shonal, good evening. Muskan, good evening. Priyanka, Amandeep Singh, good evening. Suraj, good evening. Nishanti, good evening. Mohit, good evening. Habib, good evening. Nisham, and Cricketing Effect, and Pratmesh, good evening. Good evening. Prasanna Kumar and Akash, Surya, Raviraj, Sumit, Ravikant, Amir, Kishore, Taslim, so good evening to all. Thanks for coming. And if I'm not able to read your names, I'm really sorry. Thank you so much for your time. Let's go for the session. Okay. If I'm audible, just type yes in the chat box. If I'm not audible, just type no in the chat box. I'm waiting for your chat. Am I audible? Am I audible? Just type yes in the chat box. If I'm audible, just type yes in the chat box. If I'm not audible, just type no in the chat box. I'm waiting for a chat. So good evening to everyone. Santosh, Neeraj, Yuvashri, Sumit Kumar, Durkesh, Rishabh, and Amar Singh. Okay. So thank you so much. Thank you so much. Let's start the session. Okay. Okay. So what you will learn today? Okay. So today, you will be learning the basics of embedded system design. What are the basic elements of embedded system design? What is compiler and what is assembler and what is linker, loader, and we'll be going through these definitions. And what are the different types of programming techniques, like what is in serial programming, what is in system programming, what is in circuit serial programming, what is in application programming. So we will be going through different programming techniques. What is JTAG? Okay. And common embedded peripherals, like what are the common embedded peripherals on embedded system design, starting from GPIO, what is UART, what is SPI, I2C, and what are all the controllers like DMA, what is DMA controllers, interrupt controllers, and the test and measurement equipments, like what are the test and measurement equipments generally which we use for embedded system design, and the basics of RTOS, real-time operating systems. Okay, so these are the things which we are going to learn. So if you're ready to learn, just type RTL in the chat box. Okay, if you're ready to learn, just type RTL in the chat box. Voice is low. Gautam is telling voice is low. Okay, I will increase my voice. Okay, if you're ready to learn, just type RTL in the chat box. So I'll give a short introduction about Pantech. Pantech was started in the year 2004. Like, we basically manufacture microcontroller boards, DSP boards, and FPGA boards. If you want to know more about our products and services, just log on to the website pantechsolutions.net. Okay, so our vision is to help 10 million students to learn the technology in an easy way. And so far we have trained 2 lakh plus students on YouTube, and this year, like, we have a target of training around at least 1 lakh plus students per month. Okay, so that's our vision. About me, my name is MK Jeevarajan. I completed my bachelor degree in the year 2002 and my master's in the year 2004 from College of Engineering, Guindy. I'm primarily my primary expertise is on microcontrollers and DSPs and FPGAs. Okay, I'll share you my LinkedIn link. So if you want to connect with me, I'm happy to connect and happy to help. Okay, just send me a connection request. I am sharing that on the chat box. Okay, so I'll also print the message. Give me a moment. Okay, so if you want to connect with me on LinkedIn, just send me a connection request. I'm happy to connect and happy to help. Okay, let's coming to the announcement. The attendance link will be available at 9 to 9:15 p.m. and minimum attendance required to get a free certificate is 27 days. Okay, you need at least 27 days, but you may get a waiver of 1 or 2 days. But ensure that please be present for all the 30 days so that you will have a maximum learning. And attendance link will be valid for 1 hour. Like, for the next 3 days, like, we'll be liberal. Like, we'll be activating the attendance link for more than 24 hours because a lot of new joinees are there. But after 3 days, like, the link will be valid for 1 hour, and you have to submit the attendance within once the session ends. For internship candidates, you could watch the video at any point of time and no need to submit the attendance form. All you have to do is after watching the video on the portal, you just give complete. There is a button called complete and continue on the top. Okay, you just click complete and continue. So that will mark the attendance. And that will generate the certificate once you complete the course. Okay, so you have to log in at a link called learn.pantechsolutions.net. Okay, so for some sessions, I'll be using the recorded video streaming if I'm not able to present it on live, or if for lab classes to improve the learning experience, I'll be using the recorded video sessions for teaching you. Okay, so PPT and source code downloads is available only for the paid participants, but PPT as a PDF format, I'll be sharing you on Facebook group. I'll be sharing you through email, so you could collect the PPTs in PDF format on your emails or through the Facebook group. Okay, so if you want to ask me any questions, you could ask me at the end of the Q&A sessions, which is on the live session. If I'm not present on live, if that is a recorded session, then you could ask me questions through LinkedIn or through the Facebook group. Okay, so you could reach me through Facebook group or through LinkedIn. So there are two ways to reach me if you watch a recorded session and if you have doubts and if you want to clarify the doubts. For else, you could ask me the doubts at the end of the session. If a lot of people are there, then I will be picking randomly the questions randomly and I will be answering you. But anyhow, you post the questions on Facebook group. I'll try to answer all of the questions. Okay, so that's all about the announcement. So this offer, like a lot of people are asking for, is requesting for to extend the offer for today. So we have extended the offer today. So if you could purchase all these 4 courses at 999 rupees, and the access will be for 1 year. You could access the course for 1 year validity, and you could attend the live Q&A session on every Saturday. If you have any doubts, you could ask through the live Q&A sessions on Zoom call, and you have forum support, which will be releasing the forum within a couple of days, and free soft skill sessions from Prasad Ganiraj. Okay, so these are the key takeaways. So you could enroll the offer, and it will be valid for, you could also enroll tomorrow, but you'll be getting only 3 courses: Embedded System Design, IoT, and PCB Design, okay, for the same price. So let's start the session with a mindset lesson today. So I will speak loud. Sweta Singh is asking for speak loud. Okay. Before that, let me confirm. Like, am I audible? Am I audible? Just type audible in the chat box. Let me check my mic settings. Give me a moment. Am I audible? I have the maximum volume. Okay. Am I audible? Just type yes in the chat box. Rishabh is also asking for to speak loudly. Am I audible? Thank you, Danish. Thank you, Surya. Thank you, Rajan, and thank you. Okay. Anyhow, I will speak loudly. Okay. So let's start the session with a mindset lesson today. So if you're ready to learn, just type RTL in the chat box. Ready to learn in the chat box. Okay. Just type RTL. Thank you so much for your comments. So today mindset lesson is about, yesterday I have shared you a video on the Facebook group called A Stranger's Secret from Earl Nightingale. This actually it's an audio file. It's a radio talk which Earl Nightingale given the talk at 1960s. I'm not sure about the year. It's around 1950 to 1960s. Which has created a lot of millionaires in United States. Okay, so this content is from that audio. The yesterday lesson was to mindset lesson was to decide the goal. Okay, to decide what exactly you want. So today is about your thoughts. Okay, today mindset lesson is about your thoughts. Your thoughts are so much powerful that creates you. Okay, that creates you and shapes you. No matter where you are from a lower middle class family, or no matter where you are from, but you could have your own lifestyle, okay, based on your thought process and based on your attitude. Just by changing your attitude and your thought process, you could change your lifestyle. Okay, so you should be aware of what you think most of the time. So you become what you think all day long. So you have to do an audit where what kind of thoughts you are dwell into. Like, are you dwelling more into negative thought? You just audit your self talks. Are you dwelling more of negative thoughts? Then it is going to be very dangerous. So first decide exactly what you want, and then you change your thought process and change your attitude so that you could change your lifestyle. So you could achieve what exactly you want. First, decide what is that you want. First, decide that. Okay, then change your thought process and change your attitude. Definitely, you could achieve your goal. So, Earl Nightingale, he says that a mind is like a fertile land. Okay, it doesn't care what you plant, but what you plant, it just returns. Okay, if you plant negative thoughts or if you think in negative terms, you will get negative results. If you think in positive terms, you will get positive results. So you should be aware of what thoughts you are into. So, and always think positive. I will have a separate lecture for what is positive and what is positive thought, what is positive attitude. I will give you our next lecture tomorrow. But you should audit what you think. Okay. So take an audit of your thoughts. So this is the lesson which I'd like to share you today. If this lesson is useful for you, found useful for you, like just type useful in the chat box. Okay. So that I could let know that whether the message has been communicated. Okay, just for if the mindset lesson is found useful, just type useful in the chat box. Let's go for the session. Okay, I'm waiting for a chat. Sai Ravi Teja, thank you. Okay, so thank you so much. And thank you, Laya, Nikitesh, thank you, Akil Raj, thank you, Pavan Kumar, thank you. So thank you so much. Okay, let's start the session. So today's session is about, first we will go through the basic elements of embedded system. Okay. Yesterday we have covered up what is embedded system. We have covered up the definition of embedded system and what are the types of real-time systems, what is real-time systems, and what are the types of real-time systems. And then we have covered up how to choose the right processor for your own embedded system design. So these are the things which we covered up yesterday. So today we will be covering up the basic elements of embedded system. Okay, what are the basic elements of embedded system? Any embedded system you take, you have this basic element. Okay, so you have the input variables and you have the output variables. The input variable is nothing but it may be a kind of sensors. Okay, you may have a sensors to get the values that may be the input variables. The output variables may be the display devices. It may be the LCD or it may be the TFT display or VGA. Okay, and user interface, like it's a human machine interface, like maybe a keypad or a mouse, whatever it may be, the inputs which you give to the embedded system. Okay, touch panel. So these are all the user interface. And link to other system is an interface which this embedded system design can communicate with other embedded system design or embedded systems or other controllers or other peripherals. Okay, that may be the link to other systems. It may be an Ethernet interface or UART interface or SPI interface, I2C interface, a Bluetooth, Wi-Fi. Okay, all these are wireless medium, Bluetooth, Wi-Fi, and LoRa. All these are wireless, so that are linked to other systems. Okay, so the embedded system will have this combination. Will have the input variables, will have the output variables, and you have a user interface where you could give input to the embedded system and link to other systems. The embedded system will have capability to communicate with other embedded system. Okay, is that clear? Is this slide is clear? Just type clear in the chat box. Is this clear? The basic elements of embedded system. Okay, input variables is just type clear. Okay, so coming to the sensors, basically there are two kinds of sensors. One is the analog sensors, which needs an ADC interface, ADC controller to interface with a microcontroller or a DSPs, whereas digital sensors or just transducers which transfers the value to a digital value. Okay, for example, temperature. If you take a digital temperature sensor, it gets the temperature value and it converts that to a digital value which can be directly interfaced with the microcontroller. Okay, so basically there are a lot of sensors out there. Like if you take a list, like it may be around like more than 200 to 500 sensors, maybe more than that. Okay, depending upon the parameters which you want to monitor or control. Okay, like temperature sensor, proximity sensor, and pressure sensors, position sensors. Okay, motion sensors, metal sensors, level sensors. We have a separate session for called sensors on the IoT. Like what are the consumer what are the industrial grade sensors, what are the consumer grade sensors. Okay, because it's quite different. The industrial grade will be quite different and the consumer grade will be quite different. And other devices, other protocols like Bluetooth. Okay, so Wi-Fi and LoRa module. So user interface, you have keyboard, keypad, touch panel, okay, and mouse, and output variables. You have display device like 7-segment display, or even it may be a simple LED or a TFT display or a VGA monitor or a HDMI monitor. Okay, so these are all the output devices. And coming to the IDE, okay, coming to the IDE. Before that, is that clear? Is that clear? Is the basic elements of embedded system is clear? Just type clear in the chat box. I'm waiting for a chat. Is that clear? The basic elements of embedded system design. Is that clear? Thank you, Salim. I'm waiting for a chat. So please feel free to chat on the chat box. Okay. So Taslim, thank you. Sahib, thank you. Like, what kind of Mohammed is asking which sensors used in Android mobile, like IMU sensors. You may have, there are a lot of sensors is there, like IMU sensors is there, and you have CMOS image sensors. Okay, see, that is also a sensor. A camera is also a sensor. Okay, and you have mic is also a sensor. Okay, so these are the sensors in mobile phones. A lot of sensors are there, and connectivity device like Bluetooth, GPS. Okay, GPS is also a sensor, and GSM to have connectivity, everything. Okay, so thank you so much. So what is IDE? IDE stands for Integrated Development Environment. Okay, so this IDE will be supplied by the manufacturer. Whenever the manufacturer manufactures the microcontroller, they also provides the IDE, Integrated Development Environment. And there are also third-party developers like Kale and Ride. These are all the third-party developers. Like they are the separate company where they give support for a lot of microcontrollers. Okay, so IDE will have this combination, like the compiler. It has the compiler, it has the assembler, the linker, and the loader. Okay, all these are combined together to get an IDE. This IDE will also have an editor window where you will type the programs, the C program, and it will have a console window where you could check for the errors. Okay, all the errors. If the program contains errors, that will be displayed on the console window, and the project window will give you the display of the project files. Like your project may have multiple C files, header files, and linker files. So all this will be arranged on the project window. Okay, and debug and release. So you might be finding debug and release on the softwares on most of the IDEs. When you keep under debug, it produce the symbols necessary for debugging. When you go for production, like when the code is ready for production, then it go for release window. Okay, once it's ready for manufacturing, you go for release window. So that will optimize the code. And memory window to view the memories, in the microcontroller, and register window to view the registers. Okay, and breakpoints is used to stop the execution of the program. Wherever you keep breakpoint on the source code, the breakpoint will stop the execution of the program. Whereas watch point, whenever a condition or event occurs, you could stop. It may be used in the while loop. For example, when the condition reaches 100, you could stop the program and you could check out the registers and you could check out the memories. Okay, so that's a advantage of breakpoints and watch points. It's for debugging purpose, to test whether what are the values are stored in memories and what are the values are there in registers, to check, you could stop the execution at particular location and you could check. So that's the advantage of breakpoints and watch points. And debugger is for debugging, and programming options to program the microcontroller. Okay, some microcontrollers will support ICSP, some you have to program through JTAG, and some it supports the OTA, like over the air programming or in application programming. So it depends upon the microcontrollers. Okay, so is IDE is clear? So IDE is clear. Just type clear in the chat box. If IDE is clear, just type clear in the chat box. So debug, as Gopi is asking to repeat for debug. So debug and release. Okay, so there is two options. Most of the compilers will have debug and release. So debug, when you have that in debug option, it creates symbols. Okay, the assembler creates symbols necessary for debugging. Okay, so once the code is ready, then you could choose the release option and you could release the code, the hex file. Okay, so if you check the size of the hex file, when you keep it in debug mode, the size of the hex file will be slightly more. When you choose the release option on the IDE, it optimizes the code. okay, for manufacturing. So once the code is ready, once the testing is ready for manufacturing, once you go for manufacturing, then you could choose the option, release the option, and you could generate the code hex file. Okay, and debugger is for debugging. Like for debugging, like it is using the emulator where you could debug the codes. Okay, so that is debugger. And breakpoints and watch points, you could stop the execution of the program. Okay, breakpoint is used to stop the execution of the program. You could keep a breakpoint at any place in the program, and you could stop the execution, and you could view the variables. What are the things, whether it is stored, whether the value stored in the variables are correct or not. It's just for debugging applications. Okay, watch points, whenever an event occurs, like if you could keep watch points inside of for loop or while loop. For example, if when I count reaches 50 or when I count reaches 100, then if you want to stop the program, you could use watch points. Okay, so that's all about IDE. And I have repeated the difference between breakpoints and watch points and the debug and release. So that's okay. So coming to the software design flow, like in some IDEs they have C++, you have the compilers and assemblers. So the compiler will directly give you the object file. So this object file will be linked through a linker file. Okay, you have to pass this object file to a linker, and linker will give you the hex file, which will be downloaded to the microcontroller. Okay, whereas for some IDEs, the compiler will generate the assembler source. This assembler source has to be passed to an assembler, and this assembler will give you the object file. This object file will be linked to a linker file. Okay, will linked to a linker, and finally the linker will produce the hex code, which will be downloaded to the microcontroller. And this archiver, which is, if you have used any kind of libraries like stdio or h file, and any libraries, if you header files you use, that will be in this archiver, and that will give you the library of object files. Okay, so this is a software development flow. So compiler will give you the object file. Only the object file you have to give to a linker, and linker you have to give a file called linker description file, which I will be explaining in the next slide. That will be different from manufacturer to manufacturer, so different to microcontrollers. And it is the concept is same. So once you learn, you could modify it. It will be a different style of programming. It looks like C programming, but it's a different style of programming. But you have to write the linker description file. By default, if you take the Arduino IDE, or if you take the Kale, it comes with a default linker. So it attaches the default linker and produces the hex file when you run a simple Arduino program. No need to write the linker file. But when you have a complex design, embedded system design with additional memories, with external memories, and if we have large number of data, like when you use an audio data and a video data like that, in that case you have to write the linker description file. Okay, so I will explain you what is linker description file in the next. Okay, is that clear so far? So linker takes the object files. I will give you how linker works in this slide. Okay, so is that clear? Just type clear in the chat box. Aditya is asking, I'm not understanding these technical programming terms. Will be learned about the C in this course. Like I have given the definitions. Like I'm not sure like what point is not very clear for you, Aditya. Like you could put that exactly on the chat, or you could also use the Facebook group to post the questions. Okay. Okay. So majority is clear. So I'll go for the linker file. Okay. So if you check the linker description file, okay, if you check this now, if you take a normal C program, this C program will have different sections. Okay. For example, like short M and equal to 10, short X equal to 2, short B equal to 5. These are called .C init sections. C init sections, like initialized values. These are called global variables. Okay. So that is .bss and .c init. You could find this when you run a Kale compiler. Like when you run a Kale compiler, like it will give you like .bss sections, what is the size, and .c init, what is the size. So the main program, the local variable are called .stack. Okay, .stack. And this expressions, the actual code is .text. Okay. And the standard like STD like standard input output is .cio. These are all the sections on the C code. Okay. So every C code, whenever you write a C program, okay, I just repeat, whenever you write a C program, this C program will be divided into sections, like C init sections, .bss sections, and .stack sections, and .text and .cio sections. So you have to place these sections in appropriate memory. Okay, you have to place the sections, like you have, for example, you will be having a flash memory, or you'll be having the DDR2 external, like you'll be also having the volatile memory as well as non-volatile memory. All these text sections should be stored in the flash memory. Okay, so it should exist after reset. The program should exist after reset, so that should be on the flash memory, the .text sections and .cin sections, the global variables. Okay, so all this should be stored in the flash memory. The BSS and the stack, it can be stored in the RAM memory, volatile memory. So it must be in RAM memory. So all these are, so even when you power off, it will go off. Okay, did you get this point? So for example, I'll give you the real-time case study. You have an audio player, okay, or you have an so in that case, like you if you do a noise filter applications like where you get the data from the mic. So the microphone will give you the data, will give you the analog data, so that you will be passing to your audio codec and converts that to your digital data. This digital data you have to store, and you'll be doing some noise filtering applications, so that will have generate coefficients. You'll be having coefficients, so all those coefficients or that will be in the local variables, so that you could put it on the RAM. Okay, so the code part you have to put it on the flash memory. So even when you power off the embedded system design, it should be there, the code part should be there, so that you have to place it on the flash memory. Okay, so this file will be, the linker description file will be useful whenever you have a lengthy code, like where the default linker cannot manage. Okay, so if the default, so I will just repeat, I will repeat it again. Okay, so by default, whenever you write a simple Arduino code, it has a default linker, so that will work. Okay, whenever you design a complex embedded system design, I'm talking about if you want to design an embedded system with interface with a microphone or a camera, where it has to grab the frames and where it has to process the coefficients. Okay, and segmentation, simple segmentation. Okay, it gets the frame from the camera, and if you want to do a segmentation and display on the TFT, in that case, the segmentation will have some local data, will have some variables. Okay, give me a moment. Let me switch off this. Okay. Okay, so in that case, like the variables has to be like you could store it on the RAM memory. Okay, so all the coefficients, the segmentation coefficients, you could store it on the RAM memory, whereas the actual program, it should be on the flash memory. So every C program first it will have sections like .cnit sections, .bss sections, and .stack sections, .text sections, and .cio sections. So this linker description will define you like .text. You have to place it on the flash memory. So your linker file will have two categories. One is the memory description, like the types of memory you have, flash memory or SRAM memory or SDRAM memory, and the length and the starting point and the ending point. Okay, the origin. And then you have the software sections. So the software section, you have to mention the sections to the memory, like the .var to IRAM. Okay, it looks like this. This is a sample code. The memory sections, you have IRAM, flash, and DDR. This is the starting address, and this is the length of the memory, size of the memory. And the sections, you have to initialize .bss to IRAM, .text to DDR, .cinit to flash. Okay, .cinit to flash. So these are the sections which you have to allocate the memory. So this happens only when you have more external memories and you have huge number of data. Okay, I just repeat it again. This is a sample linker file from Code Composer Studio using CCS. These are the stack and heap. Okay, stack and heap, like where when you have local variables, when you have more local variables, then you have to increase the size of the stack, else it will show error. Okay, stack and heap is for local variables. And memory, you have to define that what are the external memory you have. If you have flash memory, you have to define the flash memory. If you have DDR, you have to define the starting address, and you have to define the DDR. This origins, this is the starting address, and this is the size. Length gives you the size of the memory. Okay, the sections you have to map those sections. For example, if the flash memory don't have the sufficient size, you could still put it on the DDR and you could run the program. But the program will go off when you switch off the program, when you switch off the embedded system design. Okay, so is that clear? Is that clear? DDR stands for double data rate. Double data rate. Chinnam is DDR stands for double data rate. Okay, is that clear? Is that clear? No, the stack size and heap size. This answer is for Sandeep. Okay, nice, Sandeep. The stack size and heap size, it depends upon the local variables. Like if you have more coefficients, okay, for example, you take an image data and you have a lot of coefficients. In that case, you have to increase the stack and the heap size. It depends upon the application. Okay, it depends upon the application. Okay, is that clear? Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. Pratik, thank you. Hari, the same content available on the website for internship students. Yes, Hari, yes, the content is there. You have much more detailed content on the portal. Okay, it's what we have for this 30 days is a consolidated session of 90-day sessions. Okay, so you have much more content on over there. DDR stands for double data rate. I will be explaining, Shinu, like DDR stands for double data rate. I will explain in the next session, like the memory sections. Is that clear? Okay, so this is a PPT, like it's not an idea. Okay, okay. Let's go for the programming techniques. I have a section for memory, so I will explain you what is DDR, what is double data rate, what is DDR3, what is the SDRAM, everything in the next slides. Okay, so coming to the programming techniques, you have ISP programming, in system programming, and ICSP, in circuit serial programming, and in application programming, and then JTAG, okay, joint test action group. So ISP and ICSP, you could program the microcontrollers through serial port, okay, through serial port. And like Arduino board, what you do in Arduino board is the ICSP programming. Okay, you program the Arduino microcontroller, sorry, the AVR microcontroller, which is on the Arduino board, through ICSP program, through ICSP, like through the serial program. Okay, IAP, like in application programming, like once you deliver the product to the customer, you could program through over the air. Okay, like the mobile updates, like your mobile phone, the operating system gets updates through Wi-Fi network. Okay, the manufacturer sends the operating system through Wi-Fi. So that is in application programming, set-top box programming. Okay, one example is set-top box programming. And JTAG stands for Joint Test Action Group, like where you could debug, where you could this programming has a debugging facility, and you could also test whether the functionality testing. You could also do functionality testing on the IC, integrated circuits, or on the microcontroller. Okay. So ISPs, I just repeat, ISP stands for in system programming. ICSP stands for in circuit serial programming. So both are programming through serial port. Sometimes you could have a separate programmer for programming. Okay, so but these are all the programming techniques which you could use it on board. An IAP for in application programming, you could program through Wi-Fi, you could program through Bluetooth, and you could program through the over the air programming. Okay, through the Wi-Fi network, through JTAG, Joint Test Action Group. This is for debugging. Okay, is this clear? Is this clear? Just type clear in the chat box. Is this clear? Okay, I'll repeat, like ISP stands for in system programming. Okay, programming through serial port. And ICSP, in circuit serial programming, is same thing, and IAP is through wireless in application programming. Once you sell the product to the customers, if you want to modify the code, then you send the program through air, over the air programming. Okay, just like set-top box or through your mobile phone updates. That's an example for in application programming. And JTAG, Joint Test Access Group. Okay. So coming to JTAG, like JTAG is joint test action group. Like you have TCK, TMS, joint JTAG clock, JTAG mode select, JTAG input, okay, JTAG output, and JTAG reset. Okay, these are all the pins. So you need an emulator to program the microcontrollers, and you could do functionality testing with JTAG. So that's one advantage. So coming to the common embedded peripherals, okay, you have GPIO controllers, general purpose input output pin, where you could use this GPIO pins to interface with an LED or through sensors you could use. You have timers, okay, to count the events and to for calculating the time, and PWM controllers to generate the PWM signals, and you have DAC, digital to analog converters, as well as analog to digital converters, and you have serial communication controls like UART. UART stands for Universal Asynchronous Receiver Transmitter. It's a serial communication. And SPI for serial peripheral interface, and I2C for inter-integrated communication, and Ethernet. These are the communication controllers. And you have memory controllers, and you have interrupt controllers. Okay, interrupt controllers and DMA controllers, direct memory access controller. DMA controller, direct memory access, is used like whenever an IO device wants to use a memory, like without using the going for the controller, it could directly access the memory. So that is for the direct memory access controllers. And CAN and LIN is for automotive communications. Okay, controller area networks, and LIN, local interconnect network, is for automotive communications. And JTAG for joint test action group, again for debugging. And USB master and slave is there. You could use it for storage, you could use for communications, and video ports and audio ports, which is used for DSP processors. Apart from this, you also have TFT controllers and HDMI controllers, which I have not included, but these are all the general common embedded peripherals which you found on microcontrollers, DSPs, and FPGAs. Okay, screen is not clear. Okay, I'll increase my volume. Satyam is asking to increase my volume. I will increase my volume. So these are the common embedded peripherals. Is that clear? Is that clear? So GPIO controller stands for general purpose input output. Okay, I just repeat, GPIO controller stands for general purpose input output, like where you could interconnect LEDs and sensors to the GPIO pin. Okay, timers, which is used to count the events, to count or for real-time clock, like that. And PWM controllers, pulse width modulation controllers to generate PWM signals for motor control, and DAC, digital analog converters, and ADC, analog to digital converters, okay, to interface with audio codecs and video codecs, and serial communication controllers, like you have UART, SPA, I2C, and Ethernet, and HDMI, and you have TFT. Okay, memory controllers. Okay, memory controllers. Memory controllers is like SDRAM controllers and flash memory controllers. And interrupt controllers, you have interrupt controllers, direct memory access controllers, DMA. If any IO device wants to access the memory, like without going for the CPU, like it could access by using the DMA controllers. Okay, controller area network, and LIN, local interconnect network, and JTAG, and USB, video ports and audio ports. Okay, so these are all the peripherals. Okay, these peripherals are used to interface with the other devices. Okay, other devices. So coming to memories, okay, Anand is telling like I'm going fast. Okay, I'll try to be slow. Okay, so serial communication stands for, like, serial communication is UART. Is an example for UART. I will decrease this. I will go slow. Like Amar, I will go slow. Okay. Okay, so memories. So memories, you have primary memory as well as secondary memory. Primary memory will be very speed, okay, but it is volatile. Okay, so volatile means the program will go off when you switch off the power. Okay, so one example is SRAMs and DRAMs, but it will be very fast, very fast. SRAMs for static random access memory, and DRAM is for dynamic random access memory. In DRAM, you have SDRAM, okay, and DDR SDRAM, and you have mobile DDRs, mobile DDR RAM, and DDR3. All these are DDR stands for double data rate synchronous DRAM. Okay, it will be very much faster. Even now, they are not using SDRAM. They are using only DDR3 and DDR2, like that. DDR SDRAM is quite low. most of the like if you use a mobile device, then they will be go for mobile DDR SDRAMs. Okay, so and NVRAM for non-volatile random access memory like flash memories, EEPROM, which is non-volatile, where the program will reside even when you power off. So EEPROM and EEPROM, you have SPI based EEPROM and I2C based EEPROM, and PROM Xilinx, they use PROM technology, and masked RAM is used only or during the manufacturing process. Okay, so these are the types of memory. Basically, it has primary and secondary. Primary is very speed, and secondary it will be slow, but primary is volatile. Okay, so the program will not be there when you power off. So whereas in secondary, the program will reside on the memory even when you power off. Okay, you will, so that you have like flash memories, and EEPROM technology is there. EEPROM and PROM technologies are there, and masked ROM is there. Masked ROM is used only on the during the manufacturing, whereas flash memory and EEPROM, like EEPROM, lot of SPI based EEPROM chips are there, and I2C based EEPROM chips also is there. Okay, so so when all the coefficients will be stored, like whenever you design a DSP based systems, like coefficients will be stored only on the primary memory. Okay, so the virtual memory will be on the primary memory, so that will give you the speed. Okay, so that is primary memory. So is that clear? Is that clear? So let me check. Most of them are asking for. Give me a moment. Let me check the attendance form. They are telling that's a problem in the attendance form. Give me a moment. Okay. Okay. It's right. Okay. So it should work. It should work now. It should work now. Okay. So the attendance form, you just please refresh the attendance form. It should work now. Okay. So is that clear? Is that clear? Just type clear in the chat box. Is memories is clear? Is memories is clear? Okay. Is memories is clear? LPDDR, like what is LPDDR? LPDDR, Mohidin is asking what is LPDDR. LPDDR stands for low power double data rate. It's used for low power device like the mobile device. Okay, low power double data rate SDRAMs. Shidesh, like it should work. I think the attendance forms should work. Like you just refresh, because I'm receiving a lot of response from the attendance form. Okay, so so thank you so much. Like I'll go for the next thing. Okay, what is UART? UART stands for Universal Asynchronous Receiver Transmitter. Okay, I'm not going to much more detail in UART because we have a separate session for this. But I'll give you an overview of what is UART. It's a serial communication, and it works for a distance up to 3 meters. If you want more than 3 meters, like you have to go for RS485. And it is most widely used communication. Okay, it uses 3 wires: the transmitting, receiving, and ground. By using 3 wires, you could communicate, but the problem here in UART is both the device, the transmitting device and the receiving device, should be on the same clock, because you need to maintain the baud rate. Okay, so, since there is no clock, so it should be on the same frequency, like to receive the data. So it has a baud rate. So baud rate is how many bits transmitted per second. So both should be, transmitting device and the listening device should be on the same baud rate. Okay, to communicate. So usually it's a cross connection. The transmitting end of the transmitter will be connected to the receiving end on the receiver side, whereas the receiver side, the transmitting part, will be connected to the receiving end of this part. Okay, so this session shows this is a transmitting session, this is the receiver session, this is the transmitting, and this is the receiving session. Okay, it will have a cross connection. Okay, mostly it was used on cross connection, but there are some embedded systems, then they also use the straight connection. Okay, so Uh, so coming to SPA, UART is widely used to connect with GPS modules and wherever you need to send data for a long distance, like 3 meters, you could use UART. But you cannot connect. It's widely used for connecting two devices at a time. Okay, when you when you try to connect more than two devices on a single UART, that leads to bus contentions. Okay, so that is not recommended. So if you want to connect more than two devices or three devices, then the best interface is SPA or I2C. Okay, but but these are the interface which is used only on the PCB levels, not on the it won't go for meter level, but it is on the PCB levels. Okay, serial SPA stands for serial peripheral interface. It's a full duplex serial communication protocol. But one disadvantage of SPI is like more the number of devices you use, you need more number of GPIOs. Okay, it works on master and slave mode, single master and multiple slaves. Okay, so if you have multiple slaves, it needs additional GPIO. For example, you have 10. If you want to interface 10 devices at a time, then you need 10 GPIOs for chip select. Okay, for slave select signals. To select the slaves, you need, that's a chip select. You need 10 GPIOs. Okay, so is that clear? Is UART and SPA is clear? Just type clear in the chat box. I'm waiting for your chat. Is that clear? Is that clear? So I will answer two questions. Like Umak is asking for PROM technology is programmable read-only memory is mostly used by Xilinx. Okay, and secondary memory is the non-volatile memory. Okay, the primary memory will be the volatile memory. It should be very speed, but non-volatile memory is mostly used to store the programs. Okay. So thank you so much. Thank you, Surya. Thank you, Dir. Thank you, and Kulkarni. Thank you, Shomesh. Thank you, Shanti Priya. Thank you. GPO Dhanashri. GPO stands for General Purpose Input Output. Okay, General Purpose Input Output. Input Output. So you could use GPIO to connect an LED, to connect a switch, to connect the sensors. You could use GPIOs. Okay. Masked RAM, like masked RAM is used only during the manufacturing, like the manufacturer itself will store the program. Okay, mostly used for boot, like booting applications kind of thing. Okay, UART working distance is Nitish Kumar. UART working distance is 3 meters. If you want more than 3 meters, like you could go for RS 485 kind of thing, which will extend up to 10 to 50 meters, but not more than that. If you want more than that, then you have to go for Ethernet kind of thing, Ethernet interface. Okay. Okay, so UART stands for, see, in UART there are two types. One is clock based and another is without clock based, okay, without clock. So mostly widely used one was the without clock, like synchronous and asynchronous, okay. So in that case, you have to maintain the baud rate. So both the transmitting device and the receiving device should be on the same baud rate to receive the data, okay. Since there is no clock, like it transmits it's just a timing waveform. Okay, so it should be on the same baud rate, same frequency to receive the signal. So I will be explaining the timing diagram and much more detail of UART in the UART. Like we have one more sessions for UART for how to write a program for UART. In that we'll be going through that. Okay. So coming to I2C, I2C, like it communicates on two wires. One is the clock, another is the data. Okay, so you could have multiple slaves and you could have multiple masters. Yeah, so anything can communicate. Any device can act as a master, and it could send the data to the slave. And yeah, like you could even include, like you could have more than thousands of devices. Like I'm not sure about the exact value, but you could connect more than 1,000 devices on these two wires. Okay, so but it will be very slow when compared to SPA. It will be very slow, but anything like any device can act as a master, or any device can act as a slave. So the explanation of I2C, again, we have a separate sessions for I2C, like how I2C works and how it transmits the data and how the slave receives the data. So it's based on the timing diagram, okay? So it will have an address and it sends the address. So the slave checks for the address, and based on that, it accepts the data and sends the acknowledgement. So we will be covering much more detail on the separate sessions, the I2C and UART. So for today, like, you just know what is UART. It's a serial communication device which can communicate two devices at a time. SPI, more the device you have, more the number of GPIOs you need, but it will be it's much more faster than the I2C. I2C, you could even connect more than 1,000 devices by using these two wires. Anything can act as a master and anything can act as a slave. But SPI, only one can act as a master. You could have multiple slaves. Okay. So is that clear? Is that clear? Let's go for the next one. Okay. So this abbreviation, like master out, slave in, and master in, slave out. Okay. This is slave select. SS stands for slave select. Clock, serial clock. Okay. Serial clock and SDA. So coming to the test and measurement equipments for ESD, like you have the assembly testers for measuring the resistor value and for checking the capacitor values, especially when you have capacitors, SMD capacitors on the board. There is no value printed on that. So you need definitely you need an SMD tester for checking the this SMD tester will be required only when you have the SMD capacitors. Okay, even resistors you could check on the resistors value will be printed on that resistors. If you want to test the value of the capacitor, then you need SMD testers, multimeters. You could test the voltage and currents, and logic analyzers and protocol analyzers. For analyzing the timing diagrams of UART or SPI or for I2C, you need this protocol analyzer and you need the logic analyzer. Okay, DSO and MSO for clock to check the clock signals. So these are the essential things. But there are tools which has all the combinations, like the multimeter, the logic analyzer, the protocol analyzer, and DSO. Everything you could get it from one single tool, like analog discovery kit. Okay, so everything is there on that. These things are necessary for when you try to debug a system with DSP or a complex microcontroller or an FPGAs. Okay. So the other device you need is a short circuit locator. So most of the time you face with the embedded system design is the short circuits, which have the short circuits which was happening due to the soldering issue, or it may be to the component failure, or it may be to any like PCB fabrication failure or the short circuits. Okay, so so it takes more time to debug. So you could have a short circuit locator which will cost you nearly around 10,000 rupees. So that you could debug it very fast. Okay, and functionality tester, like whenever you have a complex design, like when you have a FPGA board which costs you around like 2 lakh rupees or 5 lakh rupees, in that case you need this device for testing the functionality of the chips. If you have a low cost board, then no problem, like you could throw it away and you could take a new board. But especially when you debug a system with FPGA where the cost is high for 5 lakh and 10 lakh, where you want to where something is not working, then you need this device, in circuit functionality testing, for testing the functionality of the integrated circuits. Okay, every integrated circuits there will be a functionality. You could check the functionality by using these testers, but usually these devices will be quite high. It will be in lakhs, like 5 lakh rupee and 10 lakh rupee, 25, mostly widely used for the complex embedded system design. Okay, there's a company called QMax Test Equipments, which manufactures these devices in India, but it's quite costlier. Like the cost will be on lakhs. Okay, so JTAC, again, JTAC is one kind of testing. With the functionality testing, like JTAC testers, through JTAC testers, you could emulate the functionality of the microcontrollers or a DSP processor and FPGA, and you could check whether it is working or not. JTAC testing. Okay, so coming to recap, like you have JTAC testing, in circuit functionality testing, PCB short circuit locator, and other testers like SMD testers and multimeters and logic analyzer and protocol analyzer. Okay, DSOs and MSOs. This protocol analyzer will be useful only when you write when you are involving writing a device driver development kind of thing. So where you have to analyze the timing waveforms, so it will be very useful for you. Okay, so Is that clear? So we have come to the end of the session. Like the next is the RTOS. Is that clear? Is that clear? Just type clear in the chat box. I'm waiting for a chat. So Bluetooth is based on UART. No, the Bluetooth modules can use a UART interface to interface with the microcontroller. For example, you take HC05. It has the way you interface the Bluetooth module with the microcontroller is through UART. Okay, any GPS or this answer is for Nitish Kumar. Okay, Nitish Kumar, like GPIO, any GPS kind of thing or GSM. If you want to interface with the microcontroller, the interface medium might be or through. They will provide some they will provide SPA interface, some they will provide the UART interface. You have to check with the manufacturers. Okay, so thank you so much. So cache memory is like a temporary memory, and it's a volatile memory, okay, which is which is used to increase the speed. The cache memory is used like the memory, the type of memory which is used is they'll be using the RAM, okay. So RAM, they'll be storing the content in RAM for cache memories, okay. Ashutosh Kumar is similar to interfacing of HC05 and LoRa. See, LoRa modules are different. Okay, HC05 is a Bluetooth module. LoRa module is the communication medium is different. Okay, sorry, the RF communication is different. Frequency is different. HC05 is a Bluetooth module, but the interface is same. There are a lot of LoRa module with SP interface, and it also has UART interface. Okay, you could choose that one. Thank you, Pavitra. Thank you. And testing methods. See, testing methods. LeBron is asking for testing methods. Say that lot of methods are there. We will have a separate session for that one because for testing the embedded, because you have functionality testing, you have in-circuit emulator testing, and how to test the circuits, how to test the boards like DFT, how to design the boards for testing. Okay, so we will have a separate session for that. Okay, so LoRa can have Mohan Krishnan, LoRa can go up to 40 kilometers. LoRa WAN can go up to 40 kilometers, but LoRa 2 kilometers also there. Modules, LoRa modules there. You check with the data sheets. We will go through LoRa in much more detail on the LoRa sections. Like we have sessions on LoRa. Okay, so we'll be going through that. How the connection, Kulkarni is asking how the connection between the microcontroller and the I2C protocol is done. We have a separate session for that. We have a separate session for I2C, okay, where I'll be explaining the timing diagram and how to write the program for that. Logic analyzer, okay. Mina second, like the logic analyzer is used to get the logic, whether it is high or low. Especially logic analyzer is widely used on for FPGAs. Okay, when you have multiple GPIOs sending the signals, whether you are getting the signals to analyze the waveforms, PWM waveforms, whether you are getting the right on time and off time, so that logic analyzer plays major role. Okay. Okay, so coming to the operating systems. Okay, coming to the operating systems. So the operating system, like so we have the operating system and the real-time operating system. First, I will explain you what is the operating system. So the operating system, it acts as a software layer between the hardware as well as the application software. Okay, so that's what happens in the operating systems. This operating system has direct access to the hardware. So this application software does not need to worry about the type of hardware. Okay, it takes care of the driver development kind of thing. Everything is managed by the operating systems. This is what happens in the OS, like Microsoft Windows, Linux, Mac OS, and Android and iOS. Okay, so all these are operating systems, whereas the embedded OS like Windows C, all these are real-time OS. Okay, so still Android and iOS, you could port it. You could port it on the embedded device on SoC, but it's not an RTOS. You could, but still you have Android and iOS can be ported on embedded systems. Okay, but that's not an RTOS. RTOS. So list of RTOS, like you have Linux, ECOS, MUSI Linux, FreeRTOS. Okay, FreeRTOS is the most widely one. So I will show you the FreeRTOS. Like I recommend to use FreeRTOS, like because it supports most of the manufacturers. Like you have Microchip, ESP32, and you Amazon also customized FreeRTOS for IoT applications. Nuvoton, okay, and Xilinx, Texas Instruments. So FreeRTOS supports a majority, and it's also like open source. And so if you want to learn RTOS, then the best thing is to choose the FreeRTOS. And we are also like planning to come up a course on FreeRTOS. Okay, so 10 days crash course on FreeRTOS. I will let you know once the course is rolling out. And it supports majority like Cypress, SIP, PSOC, Espressif, ESP32, Microchip, PIC microcontroller series, or NXP, Cortex M4 series, and NXP, okay, Nuvoton. So it supports majority. Whereas the property autos, you have to pay the license fee, okay, like QNX, VxWorks, Integrity, MOS. So if you're designing a simple embedded system or a consumer grade embedded system design, then you could go for FreeRTOS. If you're working with the hard real-time systems, then you could go with the proprietary RTOS. Okay, and so what is an RTOS? What is a real-time operating system? So it is time bound. Okay, it's time specific. It completes the task within a specific amount of time. So that is a real time. Real time operating system. So if you check the difference between the normal operating system and the desktop and the real time operating system, so when you power up the device, okay, in a normal operating system, the OS takes the control and sets up the environment, and the application runs on the top of the OS. Okay, whereas on real-time operating system, whereas the application takes control and it decides which part of the code to run. Okay, I just repeat, in desktop OS, in normal operating system, the OS takes the control, it boots first and sets up the environment, and then the application code will run. Like you could open the Microsoft Word or Microsoft Excel. Okay, whereas in real-time operating systems, whereas in RTOS, like the application takes the control. Okay, the application decides which part of the code should run. So the application is linked with the operating system on RTOS. Okay, is that clear? Is the difference between the real-time operating system and the desktop operating system is clear? Just type clear in the chat box. I'm waiting for a chat. Okay. Embedded OS, Windows C, embedded C is there. Okay. Is that clear? Is that clear? Thank you, Pratik Sharma. Thank you. And okay. Okay, thank you, Kalpesh, Rohini. I'm waiting for a chat. I'm waiting for a chat. WhatsApp group link. You could, Sajid Khan, like you could join on Facebook group if you want support. Like I'm not sure. Okay, they have shared the WhatsApp group. You please join. Okay. Ibrahim Khan is asking for repeat. Okay. See, I will repeat the desktop OS and the what is the difference between the normal operating system and the real-time operating systems. Real-time is time specific. Okay, but when you like desktop OS, like what happens is the OS takes the control and it sets up the environment. On the top, you run the applications. Like you open Microsoft Word, Microsoft Excel. Okay, it runs on the top of the OS. Whereas in real-time embedded OS, the application will decide which part of the code to run. Okay, so both the application and the operating systems are linked together. And moreover, RTOS, it's based on it is a real-time systems. It executes a task within a specific amount of time. We have seen the example yesterday, like the hard real-time and the soft real-time. Hard real-time, the system should meet the deadline almost 100%. It should not even miss a single person. One example is a airbag system. Okay, airbag system in the car. If it misses a deadline one time, so there is no use of it. Okay, so only the airbag will open only when the accident occurs. Okay, it won't open. So it misses a deadline at least one time, 1%. So that kind of system is called hard real-time systems. Okay, soft real-time systems is DVD player. If the system misses a deadline, there will be degrade in the performance, poor performance. You will get a poor performance, but there is no fatal consequences. Okay, so that is the soft real-time systems. So hard real-time, there will be fatal consequences if it misses the deadline. So real-time systems, or systems which execute the task within a particular point of time. So RTOS stands for real-time operating systems, which executes the task within a particular time. If an embedded CPU will handle only the single task, but by using RTOS, you could do multitasking on a single CPU. So that is an advantage of RTOS. Okay. So without RTOS, real-time operating system, you could do only single task on the embedded CPU. By using RTOS, you could do multitasking. You could allow the execution for multiple tasks on a single CPU. Okay, so most of the embedded system design are based on the simple while loop programming. That is a super loop concept. Okay, super loop concept. You have a while loop where you will have multiple tasks: task 1, task 2, task 3, and task 4. The processor executes the tasks one by one. Task 1, it first executes task 1, task 2, task 3, and task 4. Okay, whenever an interrupt occurs, okay, it goes for the interrupt service routine. Okay, again an interrupt occurs, so based on the priority, it goes for the interrupt service. That is the nested interrupts. Okay, nested interrupts, it's service interrupts, and come back. In that case, the super loop fails. Like, it does not have an unpredictable execution time. Okay, it does not have an unpredictable. So that you could manage these things. You could manage better in RTOS. For time critical operations, the super loop fails. Okay, because whenever an interrupt occurs, interrupt is nothing but like you watch a TV on your home, somebody rings the doorbell, you put the TV on pause mode, and you just go for opening the door and you check for them, and you come back and you resume the TV. Okay, the same thing. Whenever an interrupt occurs, the processor serves the interrupt. Okay, it goes for servicing the interrupt. It executes the interrupt service routine. From there, it comes back. So it takes some point of time there. Suddenly, if another interrupt occurs which has more priority than that, then it puts that on hold and go for the interrupt's higher routine. There it takes time. Okay, so if again it comes back, again interrupt occurs, again it goes back, again it comes back. So there is no predictable execution time on super loop concept, where you don't have on RTOS. Whereas when you use and there is no intertask communication or synchronization, there is nothing there in single task systems. Whereas in RTOS, you have multitasking, like you have intertask communication, like you have the deterministic behavior, like every task and interrupts will be handled in a defined time. Okay, so defined stack usage and task scheduling, so short ISR. So these are all the advantage of having the real-time operating systems. Is that clear? Just type clear in the chat box. Okay, thank you, Shaif. Thank you. Okay, which control board should I use for multitasking? See, microcontrollers. Vamshi is asking one doubt. Vamshi Vemula. Which microcontroller board should I use for multitasking in IoT? But it not depends upon the microcontroller. It depends upon the RTOS which you choose. See, there are some microcontrollers support RTOS. You have to check with the free RTOS. You just go for the free RTOS website and you check the type of controllers which you support. Like you could choose any manufacturers like Texas Instruments, MSP 430, or NXP Cortex M4 or ROM7. You could check and you use the concept. Okay, it not depends upon if the microcontroller supports the RTOS, then you could use the multitasking. But the super loop concept, most of the embedded systems are based on super loop. It's just they will have a simple while loop which executes the task one by one. That will not support multitasking. Okay, you definitely need an RTOS for multitasking. Okay, Vamshi. So thank you, Roshan. Thank you. Why don't we use Python? And Anand is asking, why don't we use Python language for programming Arduino? See, there are some microcontrollers, they support MicroPython. I'm not sure about the controller, like maybe ESP32 supports MicroPython. I have not worked with MicroPython frankly speaking, like I have not worked on MicroPython. I have worked on Python for FPGA on Pink processor, on Pink FPGA. I have worked on Pink FPGA deploying the AI deep learning modules YOLO algorithm on the FPGA. But for microcontrollers, MicroPython, still you could use TensorFlow and MicroPython. You could deploy MicroPython on ESP32 and Node MCU. But unfortunately, I have not worked. I have not worked on this. Okay. Kajal Jain, like the MATLAB series is on this month. Kajal Jain is asking for please start series on MATLAB. The MATLAB 30 days MATLAB, we have sessions on this month. We'll be starting at the end of Feb. Okay, maybe on 20th or 25th of this month. Okay, so coming to the recap, today class we have gone through the basic elements of embedded system design. We have gone through the compilers, assemblers, linkers and loaders, programming techniques, and common embedded peripherals, okay, and test and measurement equipments, and difference between the OS and non-RT OS. I hope the session is useful for you. Like, I'm opening for questions. Before that, I just inform, like, we have currently running a 4 months online internship program, where we have a 30 days series on embedded system design. Like, we cover up 82 architecture for 5 days with one project, and PIC architecture for 5 days for one project, and ARM7 architecture for 5 days for one project, and Cortex M4 for 5 days for one project, and Node MCU for 5 days for one project. Totally 5+ projects. Okay, you could do this 5+ projects. PPTs you could download, and source code also you could download. That is video for 1 hour for each sessions. If you have any doubts, you could reach me on LinkedIn, or you could reach me on the portal. You could join the live Q&A session on every Saturday on the community, on the WarriorSway community. And you also have the Internet of Things masterclass. We have covered up various clouds like ThinkSpeak clouds, Microsoft Azure cloud, Amazon Web Service, IoT, AWS IoT. Okay, 10+ projects on this. Much more detail for 30 days. Okay. And we have the Arduino masterclass for 30 days. Like this, it's a basic Arduino, like which gives you the overview of sensors, displays, motors, robotic systems, and electrical systems, and MATLABs and IoT. Okay, and PCB design. Okay, so this is the course which I would like to concentrate, like, because you could design your own board. If you are into embedded field, you should be able to design this. Sorry, you should be able to design the schematics, and you should be able to design your own boards. Okay. So we'll be helping you to design an 8050 microcontroller board. So that on PCB Design Masterclass. So totally of 1 or 2 days, like we can live Q&A session for 1 year, and you get the internship certificates once you complete the course on the portal, and you could download the source codes, private group access, all this for just for 999 rupees. Okay, and if you found this course is not fit for you, we have a refund policy for 7 days. You could ask for a refund, that no questions asked. So if you found if you are into embedded system design, definitely this course will help you to get the most. We also have the mindset lecture series, which will give you the right mindset for your success, because we strongly believe that 80% is accountable for success, is accountable for your mindset. Okay, so we want to tune that also. So today only offer is 999. So you will also have offer tomorrow, that will be for 3 course. Okay, embedded system design, PCB design, and the Internet of Things. So those who purchase for 750 rupees, like you will get a link. No worry, like you don't have any time for this. You will get a link. So once you make the payment for 250 rupees, 240 rupees or something, you will be upgraded to the 4 course. Okay. So I will take the questions. Thank you so much. I will take the questions. Like, I'm open to questions. Sorry, today I think we are running late for 15 minutes. Sorry. So I will open for questions. Okay. Arduino, support FreeRTOS. Arduino supports FreeRTOS, but I'm not sure about Arduino supports or not. But Arduino, there are some boards which supports FreeRTOS. You could do ESP32 supports FreeRTOS. Okay. I advise you to, instead of using Arduino, this answer is for Mohammed Tawfiq. Okay, Mohammed Tawfiq. I advise you to use ESP32, which is very much more faster than Arduino. Okay, very cheaper cost, and you also have Wi-Fi interface, ESP30 Wi-Fi. You could do IoT instead of using ESP8266. The ESP32 has an on-chip Wi-Fi. It supports Arduino. It supports FreeRTOS. Tawfiq, you just go with ESP32. Mind-blowing microcontrollers with low cost. Okay. is interrupt Rohit Roshan is interrupt have finite time for handling. How you could do that by using RTOS. Okay, you could do that by using RTOS. Sir, I purchased the combo course. Karthik, sir, I purchased the combo course. I got the payment confirmed, but I did not get the access link. Karthik, don't worry. Like you will get it today. Like it takes 24 hours time to activate. You will also have the orientation session. Like they will be calling for a orientation session on Zoom or webinar Jam. You just join the session. Like they will tell you like what to do. Okay, how to proceed the course and where to ask questions and how to join the community and how to watch the events of the community. Okay, because we are running a lot of other events, the soft skill sessions for the community, the entrepreneurs corner, like how to market and market your own products. So that instructions they will give you on the orientation sessions. Please do check on the spam also, because sometimes the emails will reach to spam. So please do check on the spam also. You'll definitely get you will email for an orientation session. Okay, you please join on the Zoom call. They will explain you like what to do next. Okay. uh, Praveen, or can Arduino be used in production projects? So Arduino is a brand which manufactures the microcontroller board. Okay, but the controller which was used in the Arduino board is the AVR microcontroller. Okay, it's an Atmaga series. Okay, you could use it depends upon the complexity of the product. Okay, if you're going to use this for a simple door lock, it will work. It won't be a problem. It's still there is a soft real time systems. Okay, but if you are going for if you want to implement a complex projects, hard real time systems, then you have to check for the you have to take the considerations like what kind of complexity you are dealing with. Okay, this is for Praveen. Ravi, yes, we have a VLSI course on FPGA. Like FPGA, like you will have the Valentine Day offer, so you could wait for 2 more days, like the VLSI course, FPGA course, which has where we cover up the Xilinx Platform Studio and the ISC, Xilinx ISC. We have not covered the Vivado part there, but ISC and the Platform Studio is there. Ravi Yadav. This answer is for Ravi Yadav. Okay. Uh, in IoT course, will first create one. Yes, Ankit Jain. Yes, in IoT course has more than 10 plus projects. Okay, 10 plus projects. You could go. You could just click the payment link, and you could just find out like what are the projects which we are giving on the which we are taking on the class. You could go through the projects. A lot of projects are there. Like so after going through the projects, definitely there are source code is there, everything is there. You could build your own projects if you want to, especially if you are in a final year project, you could use the same project for final year also. It's worth submitting the project. You could take a look on this project. Okay. Yes. This answer is for Panchakshri. I'm sorry if I'm pronouncing your name wrong. Okay. So networking devices like router, hub, and bridges or embedded devices. Yes, there's no doubt. See, actually, IoT prerequisites. See, Syed, like IoT prerequisites, we don't have any prerequisites. Like we start from scratch. Okay, no need to worry. You just grab the information and just keep on working. Don't have the habit of self-learning. Okay, definitely you will become a master on this IoT. It's not a rocket science. It's very easy. Alam Prabhu more, like you have purchased this course, you will get an email. You will get an email like you have to log into learn.pantechsolutions.net. Okay, learn.pantechsolutions.net. You have to log in to learn.pantechsolutions.net. Definitely, you will get an email. Please check the spam box too. Okay. So any questions? Any questions I have? Arduino ESP or directly used in applications or any difference? Sir, Arduino ESP or directly used in applications or any difference? Mohammed Tawfiq, like if you have ESP, when you go for ESP32 boards, that they are also manufacturing modules which you could use in products. Okay, you check for the modules also. Instead of going for the ESP32 development boards, you also check for the modules. Definitely they have modules. There are a lot of companies using ESP32 modules on their product. So you just please also check that one. Why do we use FPGA and MCU combinations? Okay. Not necessarily like FPGA and MCU combinations. It depends. Mostly the FPGA can also handle the MCU capability. Okay. If I don't know for what purpose you're using the both, but if you use FPGA, it will also do the job of the microcontroller. Maybe sometimes like I'm not sure like where you've seen both FPGA and microcontroller. This answer is for Sriram. Shubham Sriram, like why do we use FPGA and MCU combinations? FPGA can also handle the microcontroller part. I'm not sure like why they have used seven. If you have any specific case study, please let me know. How to find starting address of DDR of any memory like flash. How to find starting address of DDR? Okay, Rohit, like you have a memory space on microcontrollers. So on the you just find that you go through the data sheet of if you're using a DSP or an DSP, there is a column called memory space. Okay, you just search for memory space on the data sheets. They will have the locations like where is the DDR space and where is the flash space. Only that you can use. They will provide the starting locations and the ending locations. Okay, the datasheet will provide you the starting location. We cannot decide. Maybe on FPGA you can change. FPGA you could customize, but for DSPs and for microcontrollers, the memory space will be there. The IO space will be there. Like you check for the data sheets, you'll find out the address space. This is for Rohit Roshan. Yes, lovely soldier. Yes, we have plans for Altium. Like it will take time. Like I want to refresh because I was using Altium before in 2010. Okay, 2010. Like after that, I was not using like we used to stick with Cadence, but we have planned to do a course on Altium for 2-layer boards. Okay. Any controller recommend? Yes, you need to you can purchase 8051 low cost. Any board you purchase, low cost boards you purchase on the market for 8051, you get for 600 rupees. ESP32 you also get for 600 to 700 rupees. You could get from online. Okay, you could pick microcontroller also, you could get for 600 to 700 rupees. Okay. Nandini Chaudhary is asking for memory slide. Okay. Nandini, this memory, right? Okay, so memories, like you have primary memory and secondary memory. Primary will be very speed. Okay, so but it will be volatile. Okay, so SRAMs and DRAMs. So SRAM stands for static random access memory. SRAMs, they're not widely using now. Even DRAM, in DRAM there are different types, like SDRAM, you have SDRAM or DDR SDRAM. Okay, synchronous DRAM or double data synchronous DRAM or LPDDR. There's someone asked for LPDDR, low power DDRAM, which is used on mobile devices. So all these will be very speed, but it is volatile. Okay, whereas the secondary memory is the non-volatile memory, where you will be storing the programs, like the program code, which is stored on flash memory. So that will reside even when you switch off the microcontrollers. Okay, so sometimes they have the simple battery attached to it, but mostly it is of non-volatile. Like the program will reside even when you power off the device, like flash, EEPROM and EEPROM. These are the different types of memories. Programmable read-only memory. EEPROM, you have different kind of interfaces there, like SPA EEPROM, I2C EEPROM is there. Okay, and mask ROM is only used for the manufacturing. Like during the manufacturing itself, they will program it and they will provide it to you. That's mask ROM. It is not widely used. The widely used was flash memory. In flash, you have two categories: NOR flash and NAND flash memories. And EEPROM, you have SPA EEPROM and I2C EEPROM. Okay, if code exceeds the flash, what happens? Rohit Roshan, like if code that's what sorry, Rohit, this answer is for you. Like if code access the flash, what happens? That this will happen. This linker script, no, this will tell you like when the code this will give you an error. You will not generate the hex file. Okay, you will not generate the hex file if the code exceeds beyond the memory. That's what the linker comes to play. I'm not sure like whether you get the linker file, the message has been correctly communicated or not. I'm not sure. The linker file is responsible to place the object files on the microcontroller memory. Okay, so where to place the program part and where to place the data memory part. If in the linker file will have the length of the memory, it has a size of the memory, the starting location, the size of the memory. If the linker file knows what are all the memories there, you have to define that. You have to define whether you have flash memory or whether you have the DDR. Everything you have to define. You have to define the starting location. You have to define the memory length. Okay, so it will check for the sections. If it exceeds, you will get a linker error. Definitely you will get a linker error if the text sections, if the program sections exceeds the memory. In that case, you could put it for DDR memory, but DDR is volatile. Okay, so when you power off, the program will go off. Okay, so what the either thing, you increase the memory of flash memory and change the linker script file, and you have less memory on the linker script and you put there, then it won't work. Like for example, you cheat the linker script, you like mentioning more memories, telling that more memories on that flash memory, and you try to download this, that won't work. Okay, Rohit Roshan. So Rohit Roshan, thank you. So thank you so much for your time. Thank you. Is there any questions I would like to address? Architecture for commercial AV or okay, so ARM core is widely used. If you go with the majority manufacturers and majority of the market, the most widely used was the ARM market. Okay, ARM architecture, Cortex M4 architecture. But ARM is a company like which never, they sell only the silicon IP. They sell only the IP. They don't manufacture the chips. They sell it to the manufacturers. Like Texas Instruments purchase this IP and they manufacture the Cortex M4 ICs. And you have ARM core on NXP. Okay, there are different manufacturers. Okay, so so thank you so much for your time. Thanks for coming. Like see you on the next session. See you on the next session tomorrow. Thank you so much for your time, and see you in the next session tomorrow. Thank you. I'm signing off. Thank you.